Hey guys, this video we're going to look at arithmetic sequences. Arithmetic it just describes a type of sequence. It means adding and subtracting. So in our next lesson we'll look at geometric, which has to do with multiplying or dividing. And we're going to look at sequences and series. The difference between a sequence and a series is a sequence is a list and a series is a sum. It's the only difference between those two things. Sequence, you're just listing them all out, and then a series is a sum, which means you add up all the terms that you listed out. And again, arithmetic means it's adding or subtracting. It's a linear change. So on this, like I said, it's an arithmetic sequence, which means you add a constant year onto the preceding term each time. It's the same number over and over again. I said add or subtract because you could be adding a negative, and that would be essentially just subtracting. So, but it just comes down to adding. We would consider it to have a negative common difference if it was subtracting. We just add the negative. So arithmetic means add. So that number that you would add each time is called the common difference, which we will abbreviate with just the letter D. And in this case, you can obviously see that it would be 7 because we're just adding 7 each time. So D equals 7. So we've got two formulas we're going to look at, and there's a different way that I often like to think about this one instead. So you can just take the first term and then do n minus 1 times that common difference. That's totally fine. But a different way to do it is dn plus c, where c would just be the zero term. Sometimes we would actually call it a sub 0, just the 0 term in the list. So the 0 meaning the term before the first term. And then there's also a formula for sum right here. And we will look at this a little bit once we get into sums. But you take the first term and the last term, you add them together, and then multiply by how many terms there are divided by 2. Half the number of terms. Alright, so let's start just finding the common difference. So this goes from 9, 6, 3, 0, negative 3. It's changing by negative 3 each time. So that's the common difference. D equals negative 3. It's going down by 3. To determine the 100th term, we're going to use that formula. And we could do it either way. I'll show both ways. So the first formula that we had written there was written this way. So we need to know the first term, we need to know how many terms, and we need to know D. So looking at this, we can see that D is going up by 3 each time. We also see that A1, that first term, listed right there is 7. And then n minus 1, n is 100. And we just plug these things in. 100 minus 1 is 99. Times D is 3. And you can use a calculator for this. 99 times 3. And then plus 7. So that's 304. So that other formula that I was showing, it's basically you need the same information, except we want to find out the 0 term. So what would be the term before 7? So to do that, I just look from the right going to the left. If we're going this way, we're going down by 3, which means this number will be 4. Easy calculation. And then all we're doing with that is we're plugging it into this formula, which might look different and confusing. dn plus c, or you can call it a0, whatever you want to call it. But the reason I don't think it's confusing, I don't think it's hard, is because this is y equals mx plus b. That's all it is. B is the y-intercept, so the 0 term in this case. M is the slope, that's what we're changing by each time. And then x is just how far out we're going. So we would take that. We know d is 3. We know n is 100. And then a0 we just found was 4. So that's 300 plus 4 is obviously 304. Same answer. It doesn't matter how you get there. It just depends on which formula you like better. They're both pretty easy. All right, we're going to find the 20th term. Personally, like I've said, I like the dn plus a0. So let's find the term going back a step. So from right to left, it's increasing by 5. So if we increase by 5, this would be 12. And then left to right to get d, it's going down by 5. So d is negative 5. Oops, a0, not c. So d is negative 5, n is 20, and then a0 is 12. 5 times 20 is 100, so negative 5 times 20 will be negative 100. Negative 88. You could have done the same thing with that other formula. You do n minus 1. So 20 minus 1 would be 19 times d. D is still negative 5. So that's n minus 1 times d. Going back, looking at that formula one more time for you. N minus 1 times d plus the first term. So there's n minus 1 times d plus the first term is 7. Same answer. Doesn't matter how you get there. Either formula. Okay, so now we're going to find the sum. So we're using that other formula for the sum of the first 30 terms. But for that formula, we need to know the first term and the last term. So we need to know the 30th term. And then we're going to multiply it by 30 over 2. So we know the first term is 2. We do not know the 30th term. So that's actually where we're going to start. We're going to find the 30th term, which is exactly what we've been doing. Finding the 20th term, finding the 100th term, we're going to find the 30th term. So let's, either formula you like I said, I like to find the 0 term and do it that way, because then it's just like mx plus b. I like that formula. It's not memorizing anything new, basically, or learning anything new. So each time this is going up by 4, so d is 4, which means going back, we need to go down 4, which would be negative 2. So d is 4, n is 30, and then minus 2. So 120 minus 2 is 118. So that's that 30th term right there. So 30 over 2 is 15, times the first term is 2, plus the last term is 118. That's 120 times 15. Is 1,800. So if you add up all those numbers, you get 1,800. All right, here we are finding the sum again. This time we know the first term, we know the last term, we just don't know how many numbers are in between. So here we know that n is 1 and 2 and 3, but we don't know how many numbers are skipped over there to figure out what n is here. So that's the only part we don't know. We know the first term, we know the last term, we just don't know n. So we're going to take that same formula we were using, and you can do the dn plus a0, or you could do the a1 times, or a1 plus n minus 1 times d. It doesn't really, like I've said over and over again, it does not matter which formula you use. As pretty much always, I'm going to use dn plus a0, which means we got to find a0 going back a step. So d, always your first step, is increasing because it's getting less negative. It's increasing by 15. Which means when we go back a step, it has to be 15 less than this. So it's getting more negative. It's going to be negative 65. We would add 15 to get negative 50. And now this is a little bit different because we don't know n, but we do know that it's going to equal 400. So now this is just a one-step Algebra 1 equation. Add the 65 over, and then divide by 15. You get 31. So that's n. We know d, we already knew a1 and a30, all of that stuff, or a31, I guess. So n is 31. So we just put a 31 there. So that's 31 over 2 times 350. Now, for simplification, you can do this divide by 2 anywhere you want in this, because multiply and divide all happen together. So you could do the 350 divided by 2, or you can just type it all into your calculator. Doesn't matter. 31 divided by 2 times 350 is 5425. All right, here's another one. We know D. Looking at this, it goes up by 4, so D is 4. We know this is A1, A2, A3. We don't know what this one is, so we're going to solve that one out the same way. If we back it up a step to get the 0 term, go 4 numbers before this one. So we're going backwards. We're going to subtract 4. You get negative 3. So we know that the number 401 is going to be D times N, 4 times N, and then plus this A0, so minus 3. Algebra 1 equation, add that 3 over. Divide by 4, you get 101 equals N. So this is the 101st number in the list. Now, we obviously, this is a shortcut because we would not want to have to type in 101 numbers that we're adding up, along with finding all of the numbers in between to type out. So that's why we're using the shortcut, this formula. We look at N divided by 2 times A1 plus the last number, AN. So that's 402 times 101 over 2. And again, you could divide the 2 into either of the numbers if you wanted to simplify it. Mathematically, it works out the same way. So that's 101 times 201. It's 20301. And that's our sum. So a real life situation for this could be a theater when a theater is kind of seated like this. Maybe you only have a couple of seats here, but then you add on some seats on each side, and that's why it gets wider as it goes up. That's pretty typical. This one says each seat has 4 more seats than the previous row, so it's getting wider. They're adding on like 2 more seats each side or something like that. Probably. So how many seats are in the 30th row? So each row has 4 more than the previous, so that means D is 4. And it says that there's 26 in the first row, which means that would be our first number. If we wanted to know the number before that, if there was a row in front of that, it would have 4 less seats. So that would be 22 seats. So we could add on 4 to get to 26, and then so on. So that's D times N plus the 0 row, which would be 22. So that's 142 in the 30th row. How many seats are there altogether? So now that's adding all 30 rows together. So we need to know that there are 30 rows divided by 2. Times the first row has 26, and the 30th row we just found is 142. So that's 15 times 168. $25.20. So just a shortcut rather than adding up all the seats, counting all the seats. If you see the pattern, you can use the shortcut. All right, this last part is just a notation. If you understand the notation, it's not hard. You could even calculate these by hand. To calculate by hand, all that means is you're plugging these in. They give you a formula. You plug in these numbers. So we're going to plug in 1, we're going to plug in 2, we'll plug in 3, 4, and 5. You start from the bottom, and you keep increasing until you get to the top number, which is 5. So what this is really kind of like is I've said these were like linear equations. So it's like a table that we're just making. And to figure out the value of the table, the function, we're just plugging it into the equation right here. So you do know a way to do that with table. That's exactly what we're using. Get rid of whatever I have in here. All right, so our equation is 3m minus 4. We'll just do 3x minus 4 because that's a variable that it likes to use here. Table, and then it'll fill out our table here. 1, 2, 3, 4, and 5. If you had to go further, you'd have to, for Casios, you just have to type in the new numbers. But let's see, -1. And then 2, 5, 8. Now look at these numbers. You notice that they are going up by 3 each time. It's because the slope right there is 3. So that's why they're going to go up by 3. So the other thing is this would be the 0 term. So that means your first term is going to be 3 more than that because we're going up by 3. So add 3 onto that, you get -1. If you use that shortcut, you don't even need the list because we just know we're increasing by 3. So go up by 3, and you get 2. Go up by 3, it's 5. Go up by 3, 8. Increase by 3, you get 11. If you look at those, that's the exact numbers right there. So this notation, which is just called a sigma, it's a Greek letter. It's a capital Greek letter, but it just means sum. It just means find the sum of all of those numbers. So it's a shorthand notation, and it just says add all those numbers up. So that's -1, plus 2, plus 5, plus 8, plus 11. Those are the numbers we just wrote down. So since this is an arithmetic sequence, it's increasing by 3 each time, we can actually use our shortcut, which just means we need to know the first number and the last number. Getting ahead of myself and adding them. -1 and 11. Those are our first number and last number. And then how many numbers there are? Well, from 1 to 5, that's 5 numbers, divided by 2. So we can use that formula that we just had. So this is 2.5 times 10, or 5 divided by 2 times 10. No matter how you do that, you will get an answer of 25. You add up all those numbers. So that's pretty easy, but if you have a calculator anyway, your calculator can do the entire thing. You can actually type it in. Depending on your calculator, it's either easier or harder to type it in depending on which calculator you have. But here's the idea. So go to Option. That's where all the stuff is hidden. Option, and should be in Calc. And we're looking for sigma. It's right there. Now, this particular calculator is a little bit upgraded. It's the 9860. It's not the bottom line. So I'll show you how to type into those too. But this one just pops up with the boxes, makes it a lot easier to type in. So to do that, we just type in the equation. You can even use the letter that they're using there. By default, it's going to be capital, but you could also just use an X. It doesn't matter. Because whatever letter you use, you have to type in over here also, to make it look exactly like the original problem. So we need an M there. And a 1. And then up top, it's a 5. And we already answered this. The answer is 25. And the calculator tells you 25 as well. So that same way that I typed it, see if I can switch. Yeah. That's the exact same way that you're going to type it on the other calculator as well. Okay, so now that's opened up. Same thing, we're going to go in our Option section first, and then Calc, and we're going to scroll over to find the sigma. But this time it doesn't give you all those fancy boxes and everything, but you still type it in the same way. You would type in 3, and then your variable m, minus 4. And now rather than switching boxes, you just do comma. And we're going to type it in the exact same order we did before. So now we're going to type in the variable on the left. And then another comma. And then we'll type in the bottom number. And then another comma. Rather than going to new boxes, we just type commas. And then the top, the upper limit. Close parentheses, and 25. So the notation there is sigma, and then you type in the function, comma, I'll switch colors here to color code it, and then the variable, comma, the lower limit, comma, and then lastly the upper limit. There you are. So you type in the function first, comma, then whatever the variable was, comma, the lower, and then the upper. The commas, obviously. All right, so if you have the boxes, obviously it's easier. Most students have this calculator, which does not provide the boxes, so I'll type in a couple more this way. So we type in the function first. Comma, and then the variable is k. Comma, the lower number is 3, and then the upper number is 8. And it will do the entire work for you, negative 180. And that's super easy. Now, what this would mean, if you were doing it by hand, is you'll plug in 3, starting at the bottom, 4, and then 5, and then 6, 7, 8. Now, if we're using the shortcut, remember you don't need all of the numbers, you only need the first one and the last one. So if you only need the first number and the last one, we just need to plug in 3, so that would be 3 minus 6 times 3 is negative 15. And then we need to plug in that last number, which is 8. 3 minus 6 times 8, which is 48. 3 minus 48 is negative 45. So the formula is how many numbers we're adding up. So we're plugging in 3 through 8, which is 1, 2, 3, 4, 5, 6 numbers that we're adding up. And then the first number and the last number. And this formula will give us the answer using that formula from before. The only thing I want to point out is by counting those right there, 3, 4, 5, 6, 7, and 8, we got 6 numbers. It's not as simple as 8 minus 3 because that would be 5. Just remember that it ignores one of those numbers because you have to count those numbers as well. So when you do that, you're not counting like the number 3. So that's why there's 6 instead of a 5 that goes there. All right, so that's 3 times, this is negative 60, and then 3 times negative 60 is negative 180. Last example, same idea. If you're plugging it in and wanted to do this by hand, first thing we need to know is that from 2 through 10, how many numbers is that, counting 2 and 10? So 10 minus 2 is 8. It would actually be 9 numbers, counting the 10 and the 2. And then our first number is what we get when we plug in 2. So that's 2 times 2 is 4. Plus 7 is 11. And then when we plug in 10, that's 2 times 10 is 20. Plus 7 is 27. And then 10 minus 2 is 8. So remember that's 9 numbers in between. So that's 38 times 9 over 2. Is 171. Getting the answer by hand, or strictly using your calculator, we would just type in sigma, type in the equation. This time I'm going to show you it doesn't matter what variable you type in as long as you keep it the same. So if you want to type in an x right there so you don't have to push alpha, that's totally fine. So 2x plus 7, comma, and then the variable is x because that's what I typed, comma, 2, comma, 10. And we should get the same answer. Boom, 171, same thing. All right, that's it. Find your assignment, and in the Files tab, as always, post your comments and questions, and see you next time.